Hello folks, this is Tom from anti-proton.com, and here's a really quick video. I always say quick video and they're always really long, but this one's going to actually be quick. I just wanted to go into this because I heard it again. I swear I hear this all the time when I'm watching on YouTube. I see it when I'm watching people. I don't own a television. I don't have time for television. Television's for people with time. But I'll stop by and see somebody that has a television or something like that, and I'll hear people say this. It's just a theory. They're usually talking about evolution. People that don't understand how evolution works, they'll say it's just a theory. And, oh my God, my blood boils. It's time for me to say again what a theory, a hypothesis, and so on are. This should be very simple, and so for the 50th time I'll go through it. But anyway, here we go. Maybe this will help everybody because you really should know this, okay? There is colloquial speech. You and me just kind of talking to one another. We're not getting too deep and personal or scientific about anything, blah, 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 blah. But then there's also scientific speech, where we talk about specific things, and certain words have specific meanings to them, intrinsic, fundamental, systemic meanings. Anyway, so basically it kind of works like that. When you use the word theory when you're talking about science, for example, the theory of evolution, you are not talking about the colloquial usage of theory. Theory means I have a guess is basically what theory means when you're speaking colloquially. You're saying I reasonably guess something. That is so far from what it means in science that it's in a different world entirely. Let me go through it all. Okay. Here's how the whole thing works. Things that exist in the world are called phenomenons, events. Let us take an object. Let's take let's take this. This is a 50 million, sorry, it's not 50, it's a 150 million year old clamshell that I dug up on a paleontology dig. I'm not a paleontologist, by the way. It's one of my many hobbies. Anyway, I have a lot of hobbies. But I dug this guy up, and I sent an entire series of these that I dug up to the Smithsonian for dating, and they came back dated. These were not radiocarbon dated. These were well, you wouldn't radiocarbon date them anyway. Probably use like potassium, argon, or something. But the point is, this was dated via visual inspection. It looks like other ones that are equivalent to it, which have been radiologically dated, at about 150 million years old. So here's a phenomenon. When I take this and let it go, it falls. That is a phenomenon. We take another object, we drop it. That's another phenomenon. It's the same phenomenon. Over time we can realize that things are all falling whenever we drop them. Doesn't matter what the object is, it keeps falling. So we have a phenomenon that things fall. Alright? I sit down and write up information about this phenomenon. Here I take this large cryptosilicate from Nevada, and I drop it, I let it go and I drop it. That is a fact that it fell when I dropped it. That was a fact. That's what a fact is. A fact is a piece of information. Doesn't tell you anything about why, doesn't have any predictive powers, doesn't do anything whatsoever. It is just something that happened. It is a fact. It is a fact that I dropped this. It is not a fact that I will drop this and it will fall. That is not a fact. People think they say, oh, it's a fact that stuff falls. That's not actually true. It's a fact that it did fall. Facts happened back in time. They're not in the future. It is a fact. Now, it could be a fact that it is likely that it will fall. So much so that we can almost say that it is probably factual that it will fall. But the facts typically happened in the past. So it's a fact that this fell. It's a fact that this fell. It's a fact that we think we have a phenomenon that is objects falling. Okay? That is a fact. When a fact has been demonstrated thousands of times over and over with every object you could possibly imagine, and it doesn't matter, and we're sure that this fact always, this phenomenon always happens over and over and over, demonstrably true over and over and over and over, even if we have no idea why. It becomes a law. The law of stuff falling. We'll call it gravity. How about that? That sounds nice. Gravity. We'll call it the law of gravity. The law of gravity is the phenomenon of gravity demonstrated so many times that it becomes a law. That's basically a simple explanation of a law. You can get a little bit more detailed in your definition, by the way, of these words. I'm giving you the kind of crackerjack tour of what they are. So, laws have no predictive power whatsoever. They can tell you that based on everything, we can predict that the phenomenon will occur. I mean, they have that predictive power. You know, the phenomenon will occur with similar objects. But if we go out and find a different thing, a different object that we've never seen fall before, we cannot predict it will fall based on the phenomenon. We can test it, And then there was the fact that this fell. Apparently this is also linked to the phenomenon, and it falls under the fact. Okay, so that's one branch of everything. Okay? Now, when we try to explain why it happened, that's the whole point of science. Science doesn't exist to measure facts. Science is all about facts, but that's not what it actually does. Everybody measures facts all day long. Science explains things. Why does stuff happen? That's the whole point of science. Who gives a crap what happened? We want to explain why it happened in the future, okay? Because if we didn't realize that, I mean, we understand objects fall because we understand that's how that works. So, scientists would sit down and look at the facts of the phenomenon. The phenomenon is the thing that's happening. The facts are individual events of it occurring. They would look at the fact that this phenomenon made a rock fall, the fact that this phenomenon made a bird fall, and so on. And this whole law, if you like, of all of these facts and phenomena all put together that is called gravity, they would look at this in detail, and they would start testing it. How long does it take something to fall? Does everything fall at the same rate? Does weight have anything to do with it? Mass have anything to do with it? You know, what do times of the day change it? Things like that. And they would start looking at this. And over time, they would be gathering facts and facts and facts and facts and facts about this phenomenon, which not only bolsters the law and gives more information to the law, but eventually they might be able to develop a way to predict things. This is a hypothesis where they start determining hypotheses for predicting why it happens. They can predict that something heavier and something lighter, we can predict that they will fall at the same rate. We have a hypothesis for that. And over time, we might even be able to determine how it happens, the mechanism by it happening. In this case, you know, gravity is a field that exists. It's controlled by the Higgs boson particle because of something called spontaneous symmetry breaking and all this other stuff. But the point of the matter is you end up with an explanation of how it actually happens. That's also a hypothesis. And you start gathering all these hypotheses and everything together, and once you have enough of it to the point where the predictive power is so good that we can sit back and mathematically calculate crazy stuff like our spaceships that fly to like Mars and slingshot around it, the math required to figure out that level of predictability, when it's very solid and there's piles of evidence for it, nobody's able to counteract it, then we start saying we're going to call it a theory. A theory is ridiculously well tested. It's not that it can't be wrong, but it's that things are usually a theory when their being wrong would be like ludicrous, when it would just be like earth-shattering. Do you remember when the speed of light was potentially thrown into doubt for a short time? By God, that was a humongous claim. And did you see how much evidence was required? Did you see how many thousands of scientists flocked over to figure out what was going on? They challenged that. They lost. They were wrong. But the point of the matter is, it only takes one proven time to blow a theory to pieces. Now, if it's a humongous theory like evolution, which is incredibly well supported, or other theories like that, then it takes a humongous amount of evidence to blow it away, and it probably won't get blown away. If it's something really simple that just recently got created, perhaps it might get changed. Now, a theory can sometimes be called an applied theory. So, like theory of quantum mechanics can become the applied quantum mechanics. And what applied means, it isn't higher. All it means is that we've come up with a whole bunch of rules of how it works and math equations and such that we can generally create a framework to allow people to work with it on an everyday basis and use it for stuff. You know what I mean? It doesn't actually make it more true. It could be proven false for all we know. We just know that that's how stuff works. So what it boils down to is a hypothesis, which is a predictive model for how something will evolve over time, how something will work, how something will do stuff, and also an explanation of what causes things in the first place, either or. That can graduate to being a theory once it's super duper mega well tested. It does not become a law. And a theory is the highest thing you can get to really in science. There is a theorem, which is a separate thing that exists usually mostly in math. And I don't want to confuse people with theorems at this point, so let's look at theories. So, when I hear people say that they don't believe in evolution, well, first off, I think that's silly because pretty much all scientists believe in evolution. But if you don't believe in it for some unknown reason, if you want to make an argument against it, that's fine. Make any argument you want. That's what science is for. But for the love of God, don't say that it's just a theory, because once you say that, then automatically you have no credibility, because that's the silliest thing on earth. So look, I talked for 10 straight minutes. But you got to see some cryptosilicate, you got to see a 150 million year old clamshell, and a can of cat food. So this has been Tom from anti-proton.com. Hypothesis becomes theory.